the questions that are related to these motion problems. Okay, so now, if you have understood the key concept of what is acceleration, what is velocity, what is speed, and also what is displacement, then we can begin to provide an accurate formulas and the standard units in which each of these quantities are measured in. Okay, so upon understanding what are the SI units for acceleration, the SI units for velocity, speed and distance, and so on, displacement, then we can begin to know and be able to convert, if possibly you are given a unit which is not in its standard form, then we can begin to convert from kilometers per hour to meters per second, and just just bounce off from one different unit to the next kind of unit, depending on what the examiner wants you to find out. Okay, now with that said, now let's now begin. Let's now understand what are some of the formulas. Okay, what is the formula for acceleration? What is the formula for velocity? What is the formula for speed? What is the formula for displacement? And then from there, we can now provide also the international standard unit for each of those quantitative terms that help us to describe the motion of an object, the motion of an object per se. Now, we said that acceleration is the rate of change of velocity. Okay, so acceleration is the rate of change of velocity. This can be say that acceleration equals to change in velocity over change in time. Okay, so acceleration equals to the change in velocity over change in time. Okay, so rate means something to do with time. Okay, so the rate of change of velocity. Okay, so the rate at which something is changing with respect to time, that is acceleration. Okay, meaning we can say that velocity over time. Okay, say t2 minus t1. Okay, so now that is the formula for acceleration, which is the change in velocity, which is velocity, initial velocity, and as well as also final velocity. But you have got to find the differences in the two velocities. Okay, when an object starts to move, or when the object is set in motion, then it has the initial velocity, and then when an object stops moving, okay, it has also the final velocity. So now the difference between the final and the initial is now what will just give you the final, just in general, the velocity. Okay, so make sure you understand that. And then because you are measuring an object between two positions, okay, the time it started moving, okay, and then the time it will reach at a particular point, okay, the time at which an object will stop moving. Okay, so you also need to measure two time limit. Okay, so the lower limit and the upper limit, and then you subtract the two, you just find in general the time taken for that object to be moving in motion. Okay, so that is the formula for acceleration. Now, what are the standard units of acceleration? So acceleration will be meters. Okay, so it will be meters per second squared. Okay, so just ensure that it is set in meters per second squared. Otherwise, if it is not set in those units, then as a scientist or as a student who is taking physics, then you are actually at liberty to convert the unknown units, okay, the units that are not in standard form, to what is now the standard form. So ensure that you understand the conversion of which if you want to learn more about how to convert from one particular unit to the other unit, please check out also my video which I did on the conversion of units, which I'll put up in the link in this video. I'll put a description, or rather the link, so that you can go and watch the video just to have an understanding of how we can convert units from one to the other units. Okay, now let's move on to what is now velocity. Velocity is just okay, the rate of change of displacement. Okay, so velocity equals to change in displacement over change in time, which can be further said, meaning x2 minus x1 over t2 minus t1. Okay, that's a simple formula for velocity. I know some of you are saying, how come you are putting those things? We didn't do those things in our class. Okay, so don't worry. You shall begin to understand this thing that I'm writing so precise so that you don't get confused when we come to this kind of thing, which can just say the x2 is the final position an object is displaced, and then the x1 is just the initial position at which the object was at first, but when it is set in motion, it's got to change the displacement. Okay, it's got to change the displacement from first position to the final position. So you need now to subtract and then find out what is the difference, and that's the displacement. Okay, the total displacement. And then the time, whatever is set in motion must actually have time limit. Okay, the time bound. Okay, the initial time up to the final time in which an object is respectively, okay, measured in. Okay, so I'm measuring the object from 2 points, and then I also need the time to take for 2 points, the initial time, the starting time, and then the ending time. And then when I find out the difference between those two numbers, then I'll get in general the time it took for that object to be displaced from one point to the next point. So make sure you understand that also. Now speed is the same as velocity, except that speed will never be negative, because it is somehow, I can say it can't, because there is no change in direction. Okay, there is no change in direction. Okay, so this is a speed equals to distance over time. Yeah. Okay, so that's a simple. I won't talk much on that formula, but this is the formula that is known. But in the coming future, I will explain why that is the case as compared to velocity. So make sure you understand that velocity and speed, they are the same, except that speed will never be negative, because it does not take in consideration the change in the distance or the change in displacement. Okay, so make sure we understand that. Then finally, displacement is just the change in position. So the change in final position minus the change in initial position. So these are the formulas for derived from the definitions. Okay. Now, in the next video, we'll look at what are some of the equations of motion. Okay. So normally these, of course, they are by definition the formulas from the definition. Okay. But there is also what is known as Newton's equations of motion. Okay. There are about 3 or 4. So that is what you look at in the next episode, in the next video. So if you're new to this channel, please don't forget to give this video a thumbs up, and then also like and subscribe and share to your friends, relatives, or whom you think they also need to actually have this kind of information, and of course share with them. Okay, so I'll be much more happier if you also subscribe to my channel, just to support me and keep so that I can keep on releasing this kind of videos to you. And so that we can interact and learn more from each other. Okay, so it's bye bye, and I'll see you in the next video.